One of the interesting things about inverse functions is that we can evaluate their derivative at points without ever finding out what the inverse function itself looks like. All we need to know is what the original function looks like. So for example, in this problem we have the function f of x is equal to 5 minus 2x to the third. We're asked to find f inverse prime of a if a is equal to 7. Now we're kind of assuming here that f has an inverse function, and we should probably test first to see if it does, and I'll leave that test up to you. One way to do it is to graph it and make sure it looks like the graph is a one-to-one function. That is, that the graph passes not only the vertical line test, which makes it a function, but also passes the horizontal line test, which makes it a one-to-one function. So let's see what kind of information we have and what kind of information we need to gather to handle a problem like this. So we're interested in f inverse prime at a. That says that on the graph of f inverse, there's a point AB. So AB is on the graph of f inverse. That is, some point 7 comma something is on the graph. So how do we find out what that something is? Well, we know that if AB is on the graph of f inverse, that says that BA must be on the graph of f. Which in this case says that there's some point comma 7 that must be on the graph. So it says that our y value is 7. So let's plug it and see what happens. We're going to have 7 is equal to 5 minus 2x to the third. That says that 2 is equal to minus 2x to the third. That says that minus 1 is equal to x to the third. And that says that minus 1 is equal to x. Or in this case, minus 1 is equal to our b that we're interested in. So on the original function, the point's negative 1, 7. On our inverse function, the point is 7, negative 1. Now that we know where we're at on the original function, we can figure out what its derivative looks like and what value its derivative has at that point. So f prime of x is going to be equal to negative 6x squared. And therefore f prime of negative 1 is going to be equal to negative 6 times negative 1 squared, or negative 6. From there, in the work that you've already read about with inverse functions, we know that f inverse prime at 7 must be equal to negative 1 over 6, that is, the reciprocal.